Hi friends, today I am going to discuss continuity of a function for the 12th class. Any function is to be continuous at a certain point. So whenever we define continuity of a function, we must define at a point. So a function fx is continuous at x is equal to a if right hand limit is equal to left hand limit is equal to value of function at x is equal to a. In another words, we can say that limit x tends to a plus, that is greater than a, that is right hand approach, fx is equal to limit x tends to a minus fx is equal to fa. If these three are equal to each other, then a given function is continuous at x is equal to a. This is the first thing. Now, what is the meaning of right hand limit? That is, the value of x is greater than a. So, first of all, we write x tends to a plus. The notation is a plus. Now the second, we can write this as h tends to 0 if a plus h. What we are doing, that just replacing x by a plus h. If x tends to a, then h tends to 0. This is the right hand limit. How can you proceed step by step? What about LHL? That is x less than a, limit x tends to a minus fx, that is limit h tends to 0 if a minus h. So here x is equal to a minus h, and if x tends to a, h tends to 0. This is how can we write right hand limit and left hand limit. Also, we know that if RHL is equal to LHL, then limit exists. Class 11th concept. If right hand limit is equal to left hand limit, then we say that there is an existence of limit. Okay. Now, to solve the question in this chapter, a few formula is required from the limit of a small formula. Like first formula is limit x tends to 0 sin x by x is equal to 1. Second, limit x tends to 0 tan x by x is equal to 1. Third, limit x tends to 0 cos x is equal to 1. Fourth, limit x tends to 0 e to the power x minus 1 by x is equal to 1. Fifth, limit x tends to a, x to the power n, a to the power n upon x minus a is equal to n into a to the power n minus 1. So these are the basic formula of limit which you required while solving the question of continuity of a function. Now let us take some example. Let us take some example. First question, so that fx is equal to x cube is continuous at x is equal to 2. Solution. Now what is the value of f2 when x is equal to 2? So this is 2 to the power q is 8. Now come to the right hand limit. So limit x tends to 2 plus fx is equal to limit h tends to 0 f2 plus h. Now x is replaced by 2 plus h. Now limit h tends to 0 2 plus h whole cube. Since h is equal to 0, hence it is equal to 8. Now LHL limit x tends to 2 minus fx or limit h tends to 0 f2 minus h or limit h tends to 0 2 minus h whole cube. So this is again 8. So in this case we observe that the value of f2 right hand limit and L left hand limit, all three are equal to each other. Therefore given function is continuous at x is equal to 2. Now let us take another example. So that function fx is equal to greatest integer function is not continuous at x is equal to n, where n is integer, where n is some integer. So solution. So what about fn? It is greatest integer and this is equal to n, as greatest integer function produces only integral value. So n is itself an integer, hence the value of greatest integer function n is equal to n. Now come to the right hand limit. Limit x tends to n plus fx. Limit h tends to 0 f n plus h. Limit h tends to 0 n plus h. Now since like n is equal to 1 or h is equal to 0.01, so 1 plus 0.01 becomes 1.001. What is the value of greatest integer? This is equal to 1 because it always gives a smallest integer or equal to n. So here also n is an integer and we are adding some fractional value, so it always going to be equal to n. Now left hand limit x tends to n minus fx is equal to limit h tends to 0 f n minus h, and this is equal to n minus 1. Why? If you subtract, like if you subtract 2 minus something, so it is 1 point something, so its greatest integer function becomes 1. It always less than, so n minus 1. So what we observe here, that fn is equal to RHL is not equal to LHL. Therefore function fx is is discontinuous at x is equal to n. Therefore, if x is discontinuous at x is equal to n. Now, take another example. Question: examine the continuity of the function fx is equal to mod sin x by x when x is not equal to 0 and equal to 1 when x is equal to 0 at x is equal to 0. So in this question we have to check the continuity of a function at x is equal to 0. Now solution. What is the value of f0 at x is equal to 0? So it becomes 1 by this one. Now come to the RHL. Limit x tends to 0 plus fx. This is equal to limit h tends to 0 f0 plus h. This is limit h tends to 0 fh. This is limit h tends to 0 sin h by h mod, since s is positive, so mod sin h is also positive. So limit h tends to 0 sin h by h, and this is the formula of limit which is equal to 1. Now come to the LHL. Limit x tends to 0 minus fx. Limit h tends to 0 f0 minus h. Limit h tends to 0 f minus h. Limit h tends to 0 sin minus h mod upon minus h. So sin minus h is minus sin h, sin minus theta is minus sin theta, and mod of that is again going to be positive. So take minus common from denominator, and this is limit h tends to 0 sin h by h. So this value is minus 1 because this is the formula of limit. So here what we observe that f0 and RHL is equal but LHL is not equal, hence the given function is discontinuous at x is equal to 0. So this function is discontinuous at x is equal to 0. Discontinuous at x is equal to 0. Let us take another example. If fx is continuous at x is equal to 0, find k, where fx is 1 minus cos 2x upon 2x square, x not equal to 0, and k when x is equal to 0. So in this question, what is required? You must know that 1 minus cos 2h is 2 sine square h. This is the formula. So what is the value of f0? It is equal to k. Now come to the right hand limit. Limit x tends to 0 plus fx. This is limit h tends to 0, f0 plus h. Limit h tends to 0, fh, or limit h tends to 0, 1 minus cos 2h by 2h square, or limit h tends to 0, 2 sine square h upon 2h square. 2 cancel out, and 2 cancel out. So this can be written as limit h tends to 0, sine h by h whole square, or this is 1 square is equal to 1. Likewise, you can calculate the value of LHL also, which is equal to 1. Therefore, k is equal to 1. That is all for today. Thank you.